I will start from the definition, and then I will discuss about hypothesis, right? What is it actually, and how we have create, and what are the types, right? And the p-value, that is the probability value, we have to also know about it. And then we start test. So what are the requirement we have? So I put here, so these need to be discussed. Then we can start our test mean to say t-test, right? And we will see what are the types of t-test. Okay, so like one sample, two sample, paired, there are basically three types. And the next we will discuss in this session. I think I'm not able to cover these two topics, and three topics we will discuss after the exam: pair t-test, ANOVA t-test, ANOVA, and repeated measure ANOVA. Okay, so let's start our day and see what is the parametric. So parametric statistics are basically based on some like assumptions, right? So assumptions we have to say like some rules. I think we have to follow some rules. Okay, try to give good example, like suppose in our this session. And do you know we have some rules, right? I decided here. So when I will conduct the exam, when we will have a retake, and what will be the grade. So can you see this is my parameter, right? 0 to 19 you will not passed. Okay, so 20 to 24 it means to say you are passed. So have a look, I have decided some parameter. Okay, so that's why we can say in the stat parametric tests are the based on some assumptions rule. So a rule about what? Okay, so distribution of the population, right? So you know very well the population we discussed in the first lessons. So from which the our sample we extracted, right? Population can be 4,000, 5,000, whatever, but we cannot work on the whole population. It is impossible, right? So we try to have some small examples. So then we can have idea. All population can be like the same. Okay, so a rule can be, do you know about the parametric test need to be follow basic two rules, most important. Rest of can be there, but most important is which is without we cannot go, right? So apply the, you have to know about, if you have some data, you should know which test I need to apply. Okay, so maybe in the end of lesson, you really understand that what is actually the parametric test and what is we have about the normality, right? And normality, I think there is no need to discuss about the normality, about what is the normality theoretically and practically you have seen, right? So it is important. Okay, if your data touch the normality, in that case, you can use parametric test. Okay, next is the homogeneity. Homogeneity is also important because I didn't mention, but here I think it is very good. Like, do you know about the, in the first lesson we discussed mean, standard deviation, and variance, right? So if we have a variance in a variable, if the variances are equal, like equal variance, sometimes we say equal variance, sorry. So sometimes we can say the homogeneity, right? Not a heterogeneity, right? So there should be equal variance in your variables or features, whatever. Equal variance should be there. If it is not equal variance, so you should not apply the parametric test. Then you can ask, sir, some if we have a data, we are not able to achieve the normality and homogeneity, what we have to do? The solution is non-parametric test. We will see next time. Okay, but today we have to focus on the parametric test. Okay, so is it clear to you guys now? What we have to do now, what is the parametric test, and what are the two major requirement for analysis to apply the parametric test hypothesis? So if you are a singular, that is if you have one statement, one assumptions, that is a hypothesis. If you talk about the plural, then it can be the hypothesis. I think it is English word, I'm not going into that. So basically it is a precise testable statement. What the researcher predict will be outcome of the study. So I should say it will be initial of your study, right? It will just start or give a initial step to your study. Okay. So usually involves proposing some possible connection between two variables. Please think. So suppose, do you know we have two variables, two type of a variable in the data analysis or statistics, whatever you will see, no problem. So we have a two type of a variable, independent variable and dependent variable, right? So you will say, sir, name is very easy. Dependent mean to say which is dependent, right? Independent mean to say which is not dependent. Very good. So we can say what the researcher changes. Independent, like what the researcher changes. Okay, dependent variables will see if you are making some change, what will be the value of the dependent variable? What will be your dependent variable, right? So what the research measure, right? So this is your like independent and dependent variable. Okay, so is it clear to you the hypothesis and the variable independent and dependent? Just take example, like if you want to increasing the temperature, then there will be hot, warmness, right? So independent variable can be like your temperature. Okay, so dependent variable can be like heating or like warmness. If you will down the temperature, then warmness will be low, or maybe the cold will be there. Okay, so whenever you have data, so please try to think about it. What you want to do? What should be the dependent and what should be independent? Which is most important? This is a first step of your ladder, right? Okay, next, test hypothesis type. Yes, it is most important. In the last, I will prove everything. So hypothesis type. So in stat we have only two major types where the researcher used the hypothesis. The first is the, can you see I highlighted the blue one, null hypothesis. Null mean to say nothing. It is just like your assumptions. This is your dummy statement. You have to give a statement, then you have to prove that that's it. Okay, if you have proved successfully, then it can be the perfect objective, right? You achieved your objective by testing your hypothesis statement. So what is that? So example, mostly we state the null hypothesis like there is no relationship between the two variable, okay, which is going to be study. Okay, one variable does not affect other, right? So mostly try to use the null hypothesis with negative word. We are assuming nothing is exist in this word, right? You cannot see that there is a relationship between there. First of all, you are assuming there is no relationship or difference, whatever you will state your statement, right? Always start with this statement like no. So there should be no relationship. You have to prove, is there a relationship exist or not? If there is something is okay, you have proved with the your test or your results, then you have to say you have to prove yes there is a relationship. In that case, you have to take some decision. You have to take a decision of this null hypothesis. Try to take example, there will be no changes in the dependent. Here, have a look. So suppose maybe I will take this example in a case study here. So have a look. There will be no changes in dependent variable like a salary here. Okay, and independent variable is gender due to the manipulation, right? So this is example. I will take that one. Like salary, I will consider as a dependent variable. Okay, what will be the salary? Salary will be like if salary is low, it belongs to male or female, right? So it is good idea. This is a good example. Okay, independent variable like gender. Gender can be male or female. Salary, do you know what is the salary? Salary, which type of a scale it should be? Any idea if you have last? But one hypothesis statement is most important. This one is null. Yes, it sometime the expert or scientist can tell you, please give your alternate hypothesis. What should be the alternate? What you want to suggest to this word? Okay, based on this one. So it can be possible, but it is not mandatory, it is optional. But you should know alternate hypothesis state that there is a relationship between the two variables, right, which is being studied. Okay, so is it clear to you? So hypothesis testing is a process, is a method or way of statistical inference. Have a look. statistical inference mean to say some knowledge, right? Do you know about the data mining? Data mining mean to say if you have some data, you have to take some inference, you have to take some insights from your data. What's actually that data, right? So that is called the statistical inference. So this is the step of the data mining. You can also use that one. So okay, so now we are going to do anything, everything is in practical, so which is important. So use to data sample to draw conclusion about a population parameter, right? So population, the whole population is our parameter, remember. Okay, but sample is not a parameter. Okay, a population probability distribution, yes, I think we discussed very well normality or some other way, we saw some curves. Okay, so first tentative assumptions is made, but a parameter or a distributions. Okay, we have to think about it, hypothesis testing. Okay, one more thing important is assumptions is called a null hypothesis. I told you the symbol or the notation, I should say, I will call notation like that. Okay, so h, and like in the foot you can see this is a subscript, right? Subscript can be zero. Zero mean to say null, right? So if it is written somewhere, it mean to say it is your null hypothesis. Okay, so we have to test this h0. Okay, h0, so that is the null hypothesis. Let's start with the t-test, right? So t-test, do you know about the t-test? So basically it is for analysis for the student purpose in the starting. So you will please find a literature on the internet, what is t-test, please go for there and see. So basically it is developed for, it is designed for the students data checking. So in that case, that's why sometimes it is called the student t-test, but mostly we say the t-test. Okay, so t-test can be have different type, 2 or 3 type, but if we have a small sample, one variable, then it will call the one sample t-test. If you have a two variable, then it will call the uh, two sample t-test, right? So there are different meanings. So let's try to understand what is t-test. Okay, so independent means, so mean to say both variable should be independent, not should be dependent, not should be related, right? So okay, experimental group A, class A, and suppose there are two classes, class A, class B. So I think these are some marks, like they scored 80 and second group scored 70. You in clear, it is very clear that class B has a low marks, or maybe it can be the mean. So it is your choice, whatever you can consider. So suppose it is a mean. So mean value average is 70. Here average is good, higher. So it can easily see there is a difference between two group. Okay, so maybe the study can be like these students are more intelligent who study from that, who study with some technology, right? Please think. And the student who are study with the traditional method like books or some other things, they are like they scored a very less mark or this thing. So this type of a problem you have to check whether which students are okay, but you have to prove. With the words we cannot prove, you should have some evidence. If you have evidence, that is the stat. Okay, so class A and class B you have to prove. Okay, so statistically significant means result calculated from the data collected through the experiments test. Okay, which is not the outcome of any chance, but it is due to the specific cause, test variable. We have to go for our variables. Okay, so now the definition, sometimes we say the test, t-test is a inferential. Remember, it is a inferential statics, which tell us if there is a statistical difference. Difference mean to say significant. Have a look on this yellow part. Significant mean to say meaningful. There is two term in the stat, significant and insignificant, right? So always go you have to prove it is significant or insignificant, and I will tell you when it is significant or insignificant. Okay, so basically independent t-test compare two variable, compare two group, compare two objects, whatever you can think. So only two things, so then it's called the two sample t-test. We have to check two groups are equal or not. How we can check? First of all, you can do by the pen or paper, but it is not good. We have a tool, we have a language, we have to put function or somewhere you can easily calculate. So t value should be in front of you. Okay, and we will see how we can do it. So now independent t-test is clear to you. It is a inferential statistics which compare two group with the help of mean value. Is it clear to you? Okay, have a look. Independent t-test. So please have a look. I think the same you can draw the distribution. First one is A example. This is a B, right? So what is the basic formula of a t-test? So if we have a two group in that case, if we have a one group, the formula will be little bit different. There should be no like another variable. So general formula is we have to calculate two things: difference between the group, right? Difference between the groups. So can you see the red one is showing the difference in the mean value, average value, right? So this is it is like a difference. Okay, second, you have to divide this difference by difference within group. Mean to say your curve is flat or your curve is not flat, right? So have a look. This is a there is a more separateness here, like here. Okay, in between here. So this is for group A, within group A, and this is group B. So if I divide, I use that one, that we can have a t value. Mathematically, I pick this snapshot from internet for you help. So this is the first variable and second variable mean value, right? And divided by standard deviation and number of samples or observations, right? So this is the formula. We have to make a square root. So you can take that formula and you can have a study of that one. So t value we will have. So we have to calculate the t value. Now this formula and graph is clear to you. So that is the way we have to calculate. So in your research or your report, you have to use this formula if you are using that one. Okay, but no need to give this type of a just it is for your help. But I will tell you when you what do you have to report actually. What are the your reported results, which is important. Okay, so now I told you last previous slide, the word is significant, right? Here. So who will tell us the significant or not? P value. What is the P value? P is like a parrot? No, P is not a parrot. P is the probability. Mean to say how much you are sure, or how much you are confident, right? To prove that these results are okay. So p value measure the probability that means are different due to the chance. It also tell us whether difference is really existing or not, and you should be sure about it. You can be sure about 90%, you can be sure about 95%, you can be sure about 99%, but you cannot be sure about 100%. Because why? Because we are doing hypothetical study. These we are just testing our study, right? So never be used like 100%. Yes, it can be 99%. So if you are a 99%, then it means to say 1% chance to be wrong. Your result can be 1% vary, right? Vary, and 5% can be the error or some problem, and 95% you are sure. Here 90%, here 95, here 90%, right? So 90% you are sure and 10% you are not sure. So the p value, please have a look. Yellow is the 0.05, right? So you have to check this value. Whenever you have any test, you have to compare this p value. Basically for p value, there is a small table you can find on the internet. There is a table, there are some table, but SPSS give the automatically calculate the p value, right? So these are the some standardized value, because there is no basically these are the parameter for only for prove that significant or not significant. So p value. Okay, so instead mostly we use uh, basically these two p values, right? Because you have to give very good result. 95% is very good, 99 is also good, but if you will say 90, it is not acceptable most of time. So you have to use these parameter. Okay, it is your choice which p value you want to be check, right? Okay, whatever the result we will compare with that one. So Is it clear to you that P is the main significant value, probability value, which we can check? Okay, independent t-test. Again, I'm writing here. I told you it will compare the mean between two unrelated variable. Perfect. It will compare the two groups which are not related to each other. There is no connection, no relation in there, right? So assumptions most important. Now let's start our t-test. So before t-test, we should know about the assumptions. Assumptions mean to say rule. Do you know t-test, if you want to apply, there should be some rule. If your data has that are following the rule, then you should go with the t-test. If these rules are not followed by your data, then you please don't use the t-test, right? Please try to understand. So first rule, okay, and I will tell you which rule most important to know. Otherwise some can be use it, but almost if you will do follow all the rules, it will be very good idea. Okay, so nobody can challenge you. I think it is good. So your dependent variable should be measure on a continuous scale, right? As I told you, like a salary, right? And it can be weight, and it can be marks of the students, right? These are the continuous value, right? It means to say it should be scale variable. Dependent should be like that. So is it clear to you? Let's go for the next. An independent variable should be categorical or like nominal, right? You know very well nominal and independent groups. For example, gender. Okay. So independent variable should have a two group, not one group, right? So two group like male or female, like marital status, married or unmarried. You can have another example. Okay. Is it also clear? You should have independence of observations, which mean that there is a no perfect. Uh, I think it is also clear because can you see independent variable is suppose a gender and suppose salary or whatever weight, there is no relation, right? So I think if salary is increasing, gender cannot be increased. Please think. If salary is decreasing, gender cannot be decreased. Please think, right? So I think there is a no relation practically. So the salary and gender are just independent totally, right? They are not like what to say, not closed or related to each other, right? Okay, so next is there should be a no significant outliers. Do you remember I discussed about the outliers? Okay, so outlier maybe also we will check here. And how we can check the outlier? Okay, it is also good. So please follow these rules. Okay, if you are following that rules, mean to say you are going into the right direction. Okay, next, okay, your dependent variable should be approximately normally distributed for each group of independent variable, right? Do you understand? So now what is my dependent variables here? Weight, marks, salary, which are scale variable, right? Which are the actual numeric value. So these are the dependent variable. So we have to check here normality. What we have to check? Normal distribution is there or not, right? Do you understand? Salary variable should be normal distributed. Okay. Here I written something normally distribution for each group. It means to say each category. So I need that variable salary should be normal to the male sample should be normal and female sample should be normal. So both distribution should be normal. In that case, you are okay. If one of category is not a normal distribution, then you should not consider that data set for t-test, right? Okay, for for making a normality, there is an option. You have to remove the outliers, you have to make it clean your data, you have to solve the missing value like a mean, or maybe you can use some transformation method we have. Okay, you can improve the normality if you use the transformation with some mathematical term. Maybe I will talk about once after examination how we can transform our data, which is important. Okay, so I think, is it clear to you? These are the rules. Last one, most important, there need to be equal variance. Perfect. We have to look for the homogeneity of the variance, right? So these rules are most important to follow. If you think there should not be any challenge in your results, then it is good idea. Okay, but sometimes researchers or scientists leave that one. But remember, outlier, maybe it is good, you can consider outlier, but good idea, please not use the outlier. But these red one here, now I'm going to do the red two things. Okay, please use two important rule. Okay, so if you are following this rule, it should be, I think it must be. If one of is not following, then mean to say you should not apply the t-test, right? These can be acceptable, but please follow, right? So is it clear? This is important. If you clear these rules, then you should understand the t-test result very well. Is it clear to everyone? Okay, now I'm going to have the one case study, which is very important to study here. So have a look. Independent t-test example, one example here, only one example in this session I will consider. You can have a lot of example in your real life, you can have a lot of data, right? Please think. Okay, you can download from any website, the Kaggle, lot of websites there, you can download any data. So is there any impact? So let's understand the case study. What are the case study here? So the example to know whether the salary of a male faculty members in a private college or university is equal to the salary of a female faculty members, right? So we want to compare things, whether male faculties have a higher salary or a female faculty has a higher salary in the private institutions, right? So researchers basically collected some data like a 20 males or 20 female, and we want to know that there is a key difference or not. Okay, there is a key difference in a salary of male or female is there. This is my task or objective. So how I can write my objective or statement? So like here, is there any impact of a gender on work salary, on the work salary, right? Okay, if there is a male, is there any high salary? If there is a female, is there a low salary? Just think. So I want, this is the question in my mind. Okay, it is the question actually, right? It is the task we have to do. Okay, so if the task, what I have to do, is it clear to me now, right? I want to check. Now, based on this task, this is my objective, you can say. Do you know, I told you, uh, in our life we have objective, but in our data analysis you should have some objective. What is your objective? What you want to do? So this is the objective. And to achieve that objective, we have to give some statement. That statement is here. And what is that statement? What is this one? Anybody knows? What is this? Please.
Null hypothesis.
This is the answer, like,
No, this is the hypothesis.
yeah.
Perfect. So please think. If you want to be good statisticians, please try to be understand that you have to go follow that rules. So please try to think what we are going to do. That is the objective or task, whatever. And for achieving the objective, we have to state my hypothesis. And which hypothesis it is? Which type of
Null.
hypothesis? Null hypothesis, right? And null hypothesis will start with the no word. Okay, so you can use there is a no significant difference between male and female salary. If I will, can I prove that one or not? Yes, we have to prove my statement, right? And how we can prove, I will show you next. So if I'm able to prove, then I can achieve my objective. Okay, so I told you alternate hypothesis is also there. You can use, okay, but it is not mandatory. Okay, let's go for the test. Okay, now it is the practical part. I want to show you here nominal, which is the categorical. Scale is the continuous, right? Salary. Okay, nothing to discuss here. You know very well. The male salary is like a 45,000. Uh, Next male has the 46,000, and this male has a 54,000, right? This is the data I have. Similarly, we have the another records for females here. 23 number record is saying 34,000, and 35 number female has 34, again the same, and 46, right? So, and you know very well, you know how to use the descriptive statistics, mean, mode, median, everything you know in the first lesson you can have, right? But now our task is to be for applying the t-test. Analyze,
Uh-huh.
descriptive,
Okay, okay.
and explore.
All right. Thank you.
Here you please go to that explore bar will be in front of us, and we can drag and drop, and you can click over here. Dependent list should have your test variable, right? Okay, and your nominal variable or categorical variable should be in the factor list, right? Factor list here. So please put there. After putting it, display the result both. Yes, we need both. Plot we need some statics, right? So it is your choice. You can choose anything, but mostly we use what we
Together all.
need. I told you maybe 95% confidence interval mean to say the surety about that my result should be 95%. Okay. So I'm not talking about M estimator or percentile. I'm looking for the rule. You know, I told you outlier. It is good to use it. Okay. Okay. Now I think it is done in that button. In plot, let's see what is the second rule. Normality. Okay, so normality you want to check, you don't need that one. And yes, histogram you can print, it is your choice. So normality, yes, I can put check on the normality button. So normality will check with the some test. It will plot something for us and give some result, and normality will be checked with the one test which will you will show in the output. And please go for that test. What is that test? Okay, on internet, please explore. Okay, I can check the normality. And okay, so I can check the what I'm talking about, the homogeneity of variance, right? That is the equal variance concept. So that is basically tell us how your data is spreaded over there, right? So in that case we have the 11 test. If you want to use 11 test, right now nothing is I'm going to apply the homogeneity test, untransformed data, right? So it is for the homogeneity test. So outlier we checked, normality we checked, and homogeneity of variance I checked. Three rules, which is I think it is good to apply, right? So can I do continue? Okay, let's see what is the option. No, we have no missing value type of a data. Everything is okay. Okay, I think is okay. Now can I click on it? Yes, let's see. And the another some basic rules like independency here. So can you see there is a relation between two or not? Two variables. Gender is very different. Nominal, it is a scale. So there is a no relation. Please remember they should be totally independent, right? So first rule was this is the gender variable, that should be the what you say, that is the nominal type, and second can be the continuous like a scale type, right? These are the rule we I think followed in the previous slide here. This is important. Please check that one, right? So dependent variable should be scale, and independent I think I used. So mostly for me I think this is important. Okay, obviously these are important, but most important like significant these one. Okay, so please let me know, are you able to check your output or not? So okay, so what is the gender here? You know very well we are focusing on our objective. Let's see, there is no missing value here. Can you see the missing value? Yes, you can easily identify there is no missing value here. And male students are 20, 20, 100% data I have. This is the case summary, right? Now this is the descriptive statistics. I think in the first lecture we discussed very well what is the descriptive statistics: mean, mode, median, variances, range, IR, skewness, curtices, everything is there. You can check the normality with the curtices, skewnesses. I told you, right? Do you remember? So please remember, you have to look for the each category, male and female. Okay, each sample group need to be discussed or checked carefully. Okay, these are the descriptive values. What are the minimum salary? What are the maximum salary of the female males? You can check here. Maximum salary is 64,000. Minimum is 34. This is the basically range, and you know how we calculate the range in the first lessons. Everything was there. Okay, so it was the descriptive one. I think we covered this one. Extreme value, yes, there are some extreme value over here. The case number 6, 5, 7, 12. It can be there. The salary of a teacher for a male, that is the highest, and this is the lowest value, right? And for female, it is the highest and lowest value. But we have to include all the values right now, because we cannot remove that one. These are not like extreme values. Okay, I want to check with my outliers, with not this one. I will check with my box plot, right? Okay, now next can be the normality, which is the most important, right? Let's see what this normality test. Now please remember, I told you that we have, if we want to do some task, there are some another test we need to use. So here, can you see there are a KS test, Kolmogorov Simronov test, and Shapirovic test. Most important, mostly used, we researchers say or see, the basically Shapirovic test, that is the SW test, right? This test is used for which rule test, which rule checking? Normality, right? We have to check the normality, right? So have a look. This is the test of normality. We have to look for each category, for male and for female. For male, just nothing to do, just see the statistical value. If you want to prove, yes, obviously you can give your hypothesis, you can give your own objective, like there is no equal distribution in the male student, there is no, so you can do more hypothesis as you want, right? But right now, according to my task study, so I will not use that hypothesis, but it is your choice. Okay, so my focus is to be here. What is this one? Do you know what is this one? Significant.
It should be bigger than 0.05, this thing.
Yes, you are right, but what is the name of that one? What is the some name? Significant and insignificant. And how we can show the significant and insignificant? Here, this one. In slide, do you know? Uh, Something is here. P. What is P? Probability of the test, significance of the test, right? So you are right that that is the P value. Okay, we have to check, this is the P value by given by the normality. So now we have to understand my data is normal or not. So P value is here, is it is a bigger than the 0.05, right? Have a look. It is a bigger than 0.05. In that case, normality is there. So my data of male group is normal, right? Maybe the same p value you have there in your system. Second thing, let's go for the female. Remember, you have to check the normality for each category. If female has some issue, please go for the transformation method, right? If male has some issue, we have to go for that. So in that case, both groups are looking normal. So is it clear to you? Can you see
Yes.
this normality? So which is important. Okay, so normality is done. Now let's go for the second rule. Test of equal variance, like homogeneity of variances, right? That the data is separated over in the both groups are the same or not. Maybe some data is spread very less. Do you know about the flat curve or something? So that is the spreadness actually, right? So that is the homogeneity of the variance. We have to check spreadness in the one variable or a feature is more, or in the second. You can also state a hypothesis, right? So if you go for the internet for learning this test, so you will have some hypothesis, you will read some, I'm sure, right? But in my task, I will not use now. Okay, so you can use it like there is a no equal distribution. This is the hypothesis you want to prove. Okay, so you want to prove with this result, same. So please think, I'm going to discuss in t-test lot of things. Okay, okay, now please have a look again. What is here? We have to look only the mean, based on the mean basically. We use based on the mean, the significant value. Again, my dear students, this value is looking above 0.05. It should not be like a 0.05. It means to say there is not equal variance, right? So based on the average, I should say there are homogeneity of variance in the teacher's salary, right? So remember, we have to check this data. So please let me know from this data which is my target variable, which is my target variable where I'm checking normality and where I'm checking the equal variance. In which variable? Please let me know. Standing. So my target variable is that one, right? Great. That is the test variable. Thank you very much. So now I think it is clear. So whatever the result I have based on the salary variable, obviously the another variable that is the explain variable is the categorical variable, right? So that's okay. Okay, so I think I want to go for my test here. So I think it is good. I can check the normality is achieved. So salary is a test variable. I told you that is my dependent variable, right? And grouping variable, you know, that is our what do you say? Uh, what do you say? Sorry, that is the gender here, right? So it is done, I think. Okay, so now next is histogram. I think it is also good, like, right? It is also showing the normal curve, right? Can you see the normal curve? And you know very well how to use a normal curve. Okay, QQ plot is not important now. I think it is also good, this QQ plot, because all the observations to this slope. So only these two values there, but it is okay right now. Okay, because it is doesn't matter that you have to follow that one. You have to follow only the statistical test based on this p-value normality. You have to prove, right? Then you can do it. So now I think we have achieved all the rules. Is it clear? Is it clear to everyone? We have achieved all the rules, I think. Okay. You can see these results over there. Okay, so I think it is no more required, which is not important. Box plot, it is good. Yes, can I see some outlier? I think there is no outlier in the male data and there is no outlier in the female data. So in this diagram, average salary looking for the male guys are high and female is very low as compared to that one. Okay, we know, but we cannot see that this is a difference. We have to give the proof statistically, right? Okay, so is it clear to everyone now? Analysis, should I please do with me? Compare mean in analysis, compare mean. Here we have a lot of statistical tests, right? So you can use check the mean, one sample t-test, independent sample t-test. So I would like to go for the independent sample t-test because both variables are independent to each other. Let's go for that test. Oh, great, I can see. Please do with me. Is it okay? So now what is my test variable? What is the test variable? That is the dependent variable or my target variable, salary. Take it to there. And what is my independent variable? That is the categorical group. Let's take there. Now remember, have a look. Please click on the value labels. Can you see the code of that variable? Can you see it already encoded, right? So what is the male? 1 and female should be 2, right? So obviously we have to give a, by default it is a 1 for the male and second for the female. Okay, because every statistical test work with the numerical value. It will not work with the male or female, right? So this is the encoding. Okay, you know, you should know it. Okay, now define the group. It is okay. No missing value. It is okay, and I think it is done. So effect side is not good. We have no need. Let's see. Can I go? Okay. Okay. Do it. Can you see in the same window? I have lowered the result of t-test. So please have a look. I think this is a step I put here for your knowledge, or when you can see the slide and you can use the same one. Okay, now this is the result. So please remember the first rule. Okay, first rule was normality. We checked it here. There is no problem with the normality. Okay, now second rule was the mandatory rule was the equal variance, homogeneity of variance, right? So if your data has a equal variance, Yes, my data, this data is equal variance. In that case, we have to use the this t value here, right? 4.088 here, right? Sometime my students, we are not able to achieve the equal variance. There is a lack of, that is a heterogeneity, right? So in that case, no problem. You have a option. You can give here the second t value, right? Is it clear? So you have to report this t value if you have a equal variance. If not, you have to use that one. But in our case, we have nothing to do. This normal, this equal variance is good. It means to say p value is like insignificant over here. So zero point 0, it is a bigger, right? So then it is equal distributed. So I should report 4.088. Is it clear to everyone? For that t value, which t value we have to take? That case, the value should be different, right? SPSS give the accurate result. It will also give the some difference. Always it will give the difference here. Okay, but have a look once. I want to give the again answer of that one. So please have a look in this example. The male average salary is 49,000 something, 50,000, right? And female is a very less. You can see, sir, there is a difference. We can easily see, right? Remember, SPSS always give the difference somewhere in the mean value. There is no matter that there should be no difference. There should be difference. Here is a difference, but we cannot say this is a difference. We have to tell that is a statistical significant or not, right? So which will tell us by that test. Okay, I think it is clear now. Which is most important, which I'm talking about here, that significance level here, right? So I will talk about later the one side or two side. It is not important now. Mostly we use for a two-side t-tail test, right? Two-sided. Please have a look. Okay, so what is the p-value here? It is give, because you know this is the latest SPSS version. So here it is giving, it is less than, right here. But mostly in the oldest SPSS version, it was not the facility. Just give the only p value. But it is good that we are using a new one. So the value is, what is the value actually? 0.01. It means to say this is a very good result, right? It means to say it is a very significant value. It means the value is less than the my target probability of significance level, that is the p value. So 0.05, it is less than. I would say there is something difference. I'm sure there is a difference between two groups. Okay, I can use it. So what is that difference actually? It also calculate for you. What is the difference? 10,500, right? Say there is a big difference. 10,500 salary difference is not a very low difference. It is a huge difference. If it is a euro or if it is a dollar, it is a very huge difference. So please try to understand. So right. Okay, the standard error is not here. Difference is not standard error is, I'm not. It is not important now. So 95%. Yes, it is also good. The lower range can be salary like that, and upper range like that. The salary in between like here. You can also check that one. Okay, so I think these are the result. We have to now. Please think about how we can report the result. You can like on average male faculty members getting more salary around 49,000 with that errors than to the female, which has the mean average value 39,000 here. And this difference is perfectly significant with the t 38. What is the 38? This is the degree of freedom. Degree of freedom mean to say n minus 2 if we have two variables. If one sample, n minus 1. Okay, so how many sample we have here? I have a look. How many sample, how many observations? 40. So one for male and one for female. Okay, so here what should be 38. So we have, because we have to exclude one male and one female, because male and female itself a category, right? So that's why the better idea to use 38. Okay, so we put the t value here, and this t value is very significant because it is less than 0.05. Okay, so is it clear to you guys? Is it clear? Okay, this is the way we have to understand the result. Now you can again create a graph as you want to show the mean difference. How you can show the mean difference here? Okay, so let's see. You can use, you can delete, and here, can you see what is your gender, male and female? There is a average salary, and click on the right and create a graph. Which graph you want to make? Bar, dot, line, area, pie, as you want. Okay, so let's see, go for the bar. Maybe it will create for me. Oh, in the background, I can see. Can you see the difference? Salary of a male teacher is looking higher average salary as compared to the female teacher. And what is the difference? Here is the short difference, which I show with the graph in the starting with some sample here. That one, do you remember? I show you the that graph. Do you remember? So please try to understand. There can be this type of a graphical input here. Okay. So now, what should be the answer? So is there any impact of a gender on the work salary? Impact of a gender on the work salary? Yes. So what should be the answer from this graph?
Yes, from this graph, yes.
Right? So we have proved my task, right? But remember, we cannot say, we cannot prove our answer until we don't test the hypothesis. Until we don't test the hypothesis. Here I can see the male have a high average salary as compared to the female employee. Female hypothesis teachers. Was there is a no significant difference between male and female salary. If you remember, we created this one, right? So I will state the above null hypothesis has been rejected. It means to say if I'm rejecting, it means to say there is something difference, right? So you can write like a rejected, or you can also write I'm failed to accept. It is your choice, right? So it is rejected. It means to say oppositely, what hypothesis I should accept? Choice, which hypothesis you are considering. So most important is null hypothesis. Based on it, you can clarify your result. Based on this, you can also, this is your suggestion. You can suggest the alternate hypothesis to the people, to the world, that this is the result. Now we have, can we have a one sample t-test? Obviously we can have a t-test. I put the my question here. Is there any impact of a line next subject on the student marks? Please think. Do you know we have some computer system subject somewhere? So is there any impact of it or not? Please find. Please find if you want. Right? It
Yes.
can, it can be right. So how you can make a hypothesis? There is no significant difference between the marks of students, that is the sample mean, to the population mean, right? Sample mean to say specific your sample, and population mean to say which is the whole population mean, right? So the above null hypothesis should be rejected or accepted. What should be the p value, right? Please try to understand. Okay, so for that we need some data. Remember, I think everyone has this data, right? So let's see how we can use. I'm going very fast, please go for it. Where I can go for compare mean, one sample t-test, right? What is the my test variable? You can take any scale variable over here, the final marks, or suppose number 5th. So I want to check the test number 5, test variable, right? Oh, remember, so I want to check here test value. You have to give the test value here. You have to give the test value what? The population mean. Have a look, the population mean, right? So what is the whole population mean? Because I don't know actually. So I have to give the value. I will take here. So this is the population mean, can be around 6 or 7. I think 6 I can give. Okay. So I give this parameter. I will compare this population mean with the exact sample mean. This is the sample, one sample t-test. Okay. I will go for it. Let's see what is the result. Result in front of me. Can you see here? This mean difference, one sample t-test. What is the mean? 7.8. So what was my population mean, which I given 6. So now it is higher. So 6 and 7 has a difference, right? So from there I can see there is some difference. Okay, how I can check once again? T value, p value. Can you see the t value? P value. What is the p value? 0.001. It is very lower as compared to 0.05, right? It is very lower. It means there is a difference in between sample mean and population mean. So you can see, yes, there is a really impact of the subject on the students, right? So that's all. I think you can check very well. Obviously, before it you have to go for normality or something, you know very well how to do it. That we did. We learned about definition, hypothesis type, p-value, independent t-test, where I covered one sample and two sample. Next I will discuss about the paired t-test sample, but for paired we need a different data. So I will use another case study. Okay, then I will talk about ANOVA and some other thing in the next session, and some more topics I will try to cover. So thank you very much for